Hey everyone, today I'm going to show you how to make these nice bullet effects in your Roblox game. As seen here, I have an example of what the final product should look like, and this kind of effect should give a more realistic feel for the gun when you compare it to the normal laser bullet method. So let's get into it. Also keep in mind that for this video I will only be showing you how to create this effect and not how to implement it in any particular systems, such as a tool or a scene. I will only just show you how to produce this display effect. Although with the code that I will provide, it should be simple to implement it in your systems. Now before I show you how to create this bullet, I want to show you how it works in a technical sense. So as the function runs, what the function is going to do is spawn this part over here, and in this part is going to spawn in an attachment. This attachment here is the source, and it will spawn another attachment that will be placed at the point that we want to shoot at. Next, we will be spawning a beam that will be attached to these two attachments, which will create this laser over here. You can configure this beam to be any color, any texture, any light emission, or whatever you want, transparency, whatever else that makes it look better. So as you can see, when we reach this stage of the function, what's displayed here is a beam, and we kind of already have our bullet over here. But the nice thing about this effect is that at some point we're going to take this source attachment and we're going to move it towards the endpoint, which is our destination, and that kind of creates a shooting effect. And once it reaches the destination, it's already displayed, we're going to destroy it. So that's kind of a summary of how the function works. Now let's get into creating the function. Now for this function, I'm going to be using a module script, this so that we can call this function from any script, which is super convenient for large games with a lot of scripts that potentially want to call this function. This module script can be put anywhere as long as the script you're trying to call it from can access it. So for example, if you're going to run this function from a local script, I suggest putting the module script inside replicated storage. For now, I'm just going to put it in workspace. Now we're going to get to coding. So first of all, we're going to call the service, which is pretty much the only service that we need for this, which is tween service. This is the service that will help us move that source attachment smoothly towards the endpoint, as I showed previously. This is pretty much the only declaration we need to put outside of our function, so we're going to start our function here. Now the important part here is the arguments of the function. When you're going to call this function, maybe you want to shoot the bullet from a different source or to a different point, or maybe you just want the bullet to have different colors. So here I'm going to provide the following arguments. Source just going to be where the bullet will come from, the point where the bullet is traveling to, and the settings. The settings here is going to be a table, which I will elaborate later. We're going to need this in a moment, but for now these two are very important, as this is what will determine where our bullet will be. Now there are two elements that we require to set everything up, and that is the vector direction of where the bullet is traveling and the distance between the 2 points provided. We will use these arguments to create those. So let's start with the direction. What we're going to do is do point minus source unit. This will basically tell us the direction from the source towards the point. And for distance, we will do the same thing but dot magnitude. This is the distance between the source and the point. We're going to need this to set everything up. Now we're going to create our part. So I'll do local cbullet equals instance.new equals part. Now for this cbullet, make sure you anchor it so it doesn't go anywhere, and make sure you set the can call height to false so that the players don't bump into it. And for safety, you can just make it very small, like so, and make it transparent as well, because we don't want to show this bullet to anyone. We only want to display the bullet. Now we're going to parent this inside the workspace, and one thing we need to do with the part is to set it at where the source is. And one important thing is that we need the part here to look towards the point. This is so that our attachments know where it's going. So for that, we're going to hold on. Should put parent over here because we're parenting this. So for the position, we're going to use cframe. We're going to use cframe.lookAt, which this function requires two arguments: the position and the position that the cframe wants to look at. So over here, I'm making it be originating at the source position, and we're going to make it look towards the point. So we're kind of done with our bullet part for now. Now we're just going to create the attachments. So I will do a30.new attachment, and because this is the source attachment, we're just going to put it at 000 because it's already where we wanted it to be, and we're going to parent it inside the bullet that we just created. As for the second attachment, this is where it will be placed at the point. So you can either do world position equals point, or you can just do position equals vector3.new 0 and negative distance. Okay, and let's just parent this inside the C bullet as well. Now that we're done with the attachments, now we just need to create the 3D beam. So we can do local beam equals instance.new beam. And now for this beam over here, this is where the settings argument will come in, because this settings here will provide the properties that we want to set for our beam over here. So what we're going to do here is iterate through every property that's provided in the settings and set the beam's property to that value. But first of all, we want to check if the settings exist, because sometimes when you run this function, maybe you don't want any settings, you just want a simple beam, and you can just leave this nil. So we're going to check if it exists. We're going to use it. So for property value in pairs, settings do, and then the beam property equals star. This will set the property of the beam to the value provided, and that should be it for the settings argument. Additionally, you can set a default settings variable up here, so that if there are no settings, you can simply default it to this, or if there's no property that wants to override in the settings argument, we will just use the default one that we have. So we're just going to put it down here on top of the settings, and do for property value in pairs default settings do, and we'll do the same thing. Some advice that I have in the configuration of the beam is that if you want to have a texture, make sure to set the texture speed to 0 and the texture length to 1, so that the texture doesn't move around unless you want that to happen. You also want to make sure that face camera equals true, so that it doesn't look flat at certain angles. So after we configured our beam, we're going to set this beam's attachment to our attachment that we just created, like so, and then we're going to parent it inside the bullet that we just created. So now we have the So now we have everything set up. Now all we need to do is just tween this. Is just move this attachment towards the endpoint. So first of all, what we're going to do here is we're going to wait a bit because we're going to wait a bit before moving, as we want to display the full beam for a little longer before moving it. Now we're going to create a tween track from tween service. We're going to be tweening this first attachment, so like this. And for the tween info, we're going to be using 0.2 seconds and set the easing style to linear. Now just setting it to 0.2 will actually create some inconsistencies, because for example, let's say we fire a bullet to a wall that's 1000 steps away and another one towards a wall that is 50 steps away. Both bullets are going to reach their destination at the same time, which isn't really logical. So for this one, we're going to use the distance variable to our advantage, and you can create this formula like so. And this formula makes it so that the farther the bullet is, the farther the distance is, the longer it will take for the bullet to travel. So in this instance here, this basically means if the distance between the source and the point is 25 steps, it will take exactly 0.2 seconds for the bullet to reach. And if, let's say, that distance doubles, let's say the distance was 50, it will take 0.4 seconds. So now that we've done that, let's set the position to the same position as the point, because that's what we want to do with the first attachment. Alright, and now we're going to play this track, and at this point it will move the first attachment towards the endpoint. Now technically this is the end of the function, but it should be important to note that after we display a bullet, we need to destroy it as we're done with it. As you can see, we've created a bunch of new instances, and if we don't delete them, it will just stay there. So we're going to clean this up. So what we're going to do is to wait until this track is completed. This will tell us when the attachment has finished traveling towards the destination. And once that's done, we're simply going to destroy this bullet, and that should be it, because everything was parented inside this bullet. So that if we destroy this one, all three of the instances we created will also be destroyed. And that's pretty much it. One other thing that we can do is wrap this entire thing over here inside a task.spawn function. What this does is it runs the code inside without delaying any other code that's ahead of it, like so. So if I run this, it will immediately fire this one as well, like it doesn't wait for everything, it will just fire simultaneously. Now to call this function, we're going to use a local script, and we're going to put this local script start player scripts. This will basically run it as soon as the player joins. Now we're going to require the bonus script first, so because it's in workspace, I'm just going to call the module bullet for now in the script. I'm going to do require and workspace, I'm going to wait for child module script, and we're going to make it shoot forever, every 1 second. And we're going to fire this function. Like as seen over here, we need a vector3 for source, vector3 for the point, and a settings which is optional, because as seen over here, we check if it exists, and if it doesn't exist, the code should run fine. So I'm just going to not provide settings for now. What I'm going to do here is shoot from the origin and then shoot the bullet 100 steps up. So we will shoot 100 steps up, and let's see if it works. Okay, it seems we have a error over here, and the error here is a simple misspelling. It should be easily fixable. Let's run it again. And as you can see here, our bullet is shooting. Now it doesn't look so pretty because it's at a very far distance. Let me just shorten the distance a bit. And as you can see here, you have a bullet effect, and it works. You can also configure anything you want. So let's say I want to make the bullet blue. You can just add a table over here and set the color to the property we want. Now, something to note is that beams don't accept color trees, they accept color sequences. So you need to wrap your color into a color sequence before you add the color in. So I'm just going to make my bullet blue over here. Now the bullet should be blue. And as you can see here, the bullet here is blue. As you can see, it's very configurable and it's very flexible. You can run this anywhere you want. And that's pretty much it. So I hope this helped. I'm actually planning on showcasing how to do other effects that can be seen in my game Arena Tower Defense. So if there's enough support, I will go ahead and do those. But that's all for now. Goodbye.